All right, Professor Jung, let's dive into week 10. All right. So first, as always, importing libraries. We're using Darts for the modeling, NumPy, time, and then all these various models within Darts, as well as Optuna for integration and plotting. It's PyTorch for callbacks to the data sets we're using. TQDM for that, sklearn, and pandas. All right. Starting off, we got our data pre-processing. We're loading the data sets from my file location for the one from the time series competition. And so those are the seven. And here's our target data in the form of the family list. And so it's pulling the family um, column and the store column. Here it's merging, sorting, and doing the data typecasting for setting up this data we're about to get into. And then here's just taking the time series objects and arranging them in a dictionary so that we can find the correlation between all these data sets and extract our data, specifically the sales data from those product families. And then so the list, it's going to merge the data and it's going to put it in this format or group it by this format. Due to time constraints, I'm gonna have to turn this up. And next, we're gonna do transform the sales data that we just collected and apply it to transformations, which will clean and normalize the data in here. And that's going to be with this missing value filter, the static covariates, and the scalar in this mapper. Using all that to create a list using the time series. After all that stated data, give it to us in that format. Now we're transforming that data finally and from the callbacks to create, we're going to do the 7-day and a 28-day moving average. It's going to extract the attributes for the period within that time. And then here it's going to display the various ways we can chop up into those metrics. Transform the data using scalars. So now it's going into the data, oil price as well, doing the same thing with the moving average. And then again with transaction data, the moving average for transactions. Now the holiday events, same thing over and over again. And just for each of those various files we have above. Okay. Now it assembles all the data and deletes the original formats to save memory. I would run some of these, but I'm only going to run the plots because they take a little bit to run. And so I'll run this one. It's where it extracts the time series from the data dictionaries and gives it to us in the bread bakery and then the celebration formats. So we can run that. And here we go. Here is the time series analysis of the data sets. See the bakery sales are kind of all over the place. Definitely driving it more than the celebration sales. And then this is going to be the seasonality plot. And it's going to scale the information with, again, the missing filter or the missing values filter and all that to plot the data. So there's our first plot, and it's going to be working on the second. It's going to take a little bit longer to spit all those out. So you can wait on that. And then this is going to be plotting the sales moving average terms. So here we go for time series, last 365 days. And then after scaling, you can see the differences there. Some blocks of bad information. You can do the same for the moving average. We can see the 7-week and then the 28-week. Also the promotion data, transaction data, oil price data, covariates, holiday and event. And it's all doing the same thing, just plotting our information. So there's the promotion data with the 7-28-week moving average, transactions, oil price, and the time-related covariance. Kind of all over the place, a little hard to read that one. And now the various holidays and events that it is following, which is pulled from the data. So now for the simple baseline models and backtesting. Right here, this is using darts to set up the modeling for the naive, seasonal, exponential smoothing, and profit for the data processing and modeling the seasonality and trends of that data. And then it's going to backtest to see how the data might have performed in the past, if it had been in the past. So evaluate backtesting through these series and forecasts, plot our data. And then this is for the naive, exponential, and then profit models. And then here are just some evaluation calls for visualizing our data. Where we go. Now while that loads, we can move on to the next. This is further backtesting, and it's going to plot backtest based on month horizon, and it's giving us the transform data, which in the transform series, which naive seasonal, and then it's or celebration series transformed is the transformation series, transform series, and then this 2016-1101 is the date, and then it wants to go 16 steps in the future, and then moves the training window those 16 days, and retains the information and then keeps the points for the visualization. Here is that, oops, original backtesting with the 16-month horizon. See the actual versus the naive forecast, the exponential forecast, and the Facebook profit forecast. Now in store 12 for the celebration data with those same metrics. Now for the training and test splitting performance comparison, training and test data split performance comparison. This is just giving us an example and plotting it. We can see the training data and the validation. Now for forecast error models, we have smoothing models and forecast. Here's exponential smoothing. Gives us the forecast for the list of the trained models. Same for exponential smoothing. And gives us the start time, end time, and then the execution date. And these are the RMSLE scores, which is just a function for exponential smoothing and forecasting. And this just I have here that it iterates over the training list and fits the time series to the model for all three of the models we discussed. And how it's going to train the data using the family list to get that pre-processed data we used earlier. And it's going to do the zero forecasting for any of the values that are equal to zero. And then it's going to optimize performance and give us something. I can run this one, but it's just going to be loading the data. I just want to show you that it works. Now for the RMSLE scores, we're going to reformat the data, flatten it so that we can get it into a single list and apply that to each family and then give us the results. Let that go. Just further reformatting the data to populate the list. Does it for all of the models, calculates, and then gives us our outputs. Yeah, it's gonna take a little bit to load, so we might not be able to see that tonight. Similar stuff. Print the results for the 33 different sources for the families. Okay. We go into this. This moves the future covariates back to the past and then splits them in the various data validation ways or whatever. It's just building the model. Significant run, which builds the model and then returns the model. This is the part I really struggled with. It seems the data sets were a little too large for what I could handle. And as I was going through these, I eventually came to a point where I couldn't get it to work anymore. And I ran out of time. So this is going to be partially completed assignment this week. As you can see, this is taking a little bit to load. I just think going with the demand forecast sample data took a lot longer than expected and might have been a little too much for the skill level and should have stuck to the original data set. But that being said, that was my week 10. Thank you very much.